PUC1 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good evening, my dear students. Anybody is in the live stream? Today we have separated PUC1 classes from the combined trigonometry revision of 10th standard. Now we'll start the first chapter, the sets. And this particular set theory is one of the important theory to develop modern mathematics. Let us try to understand some basic concepts. We'll divide the chapter into three topics. Conceptual topic 1, the introduction part of what is a set, and the methods of representation of the sets. Representation of the sets we'll be studying. Representation. Second topic, conceptual topic. C stands for conceptual topic 2, types of sets. Types of sets. And the third topic is operations of sets. Operations of sets. Right. What do you mean? What is the meaning of set? Whenever we use the term set, it stands for collection of objects. Like set of different types of triangles. You know, the triangle, isosceles triangle, equilateral triangle, scalene triangle, right angle triangle, set of triangles. Set means set means set. The dictionary meaning of set is collection of objects. Collection of objects. The meaning of the sets is collection of objects. And to suppose that you want to define a set. Set is defined as a collection of well-defined objects. Let us write the definition. We'll try to understand the meaning of it. Definition of a sets. A set is, you can open your notebook and pen and write important terms, theoretical concepts. A set is a collection of. A set is a collection of. A set is a collection of. Collection of well-defined objects. A set is a collection of well-defined objects. A set is a collection of well-defined objects. See, what is the meaning of well-defined? Means the elements of that set should be well-defined, means meaningful. They should fit into that. A set is a collection of well-defined objects. If the objects are not well-defined, then it is not called as a set. Not called as set. First of all, you have to understand, not called as set if the objects are not well defined. if the objects are not well defined. For example, if I take a set of or collection of or set of best novel writers, if I take is it a well defined? See here, best novel writers, if I take. So for some people, some novel authors may be the best. For some of them, some authors will be best. It is an individual choice. Therefore, this particular set of best novel writers is not a collection of well-defined objects. And if I say not a set, understand what is not a set. If you understand not a set, then you can understand. Or you can say set of dangerous species or animals, species on the earth. See, there are infinite number of species are present, animals are present. Out of them, we cannot say which are dangerous, which are not dangerous. Some of them may be visible, some of them may be not visible. Right? Some bacteria, viruses, even we have not yet discovered. Corona was not known unless it was attacked. So therefore, dangerous species on the earth is not well defined. Therefore, it is not a set. Try to understand first of all what is not a set and what is a set. This difference you have to understand first before you continue with the study of the sets. Means a set is defined as a collection of well-defined objects. For example, if I say a set of PUC 1 students of height 12 feet. If I say set of PUC 1 students of height 12 feet, is it a possible set? Yes, sir. Height students will be there. PUC 1 students is well defined, but height of 12 feet will not contain any element. But it can be called as a set, but this set is called as empty set. There are no students who are of height 12 feet. Null set you can say, but it is a collection of PUC 1 students is well defined. And if I take a set of vowels in English alphabet, okay, I will take another set. Another example. Set of vowels in English alphabet. If you take English alphabet, set of vowels in English alphabet, yes, it is well defined. You can write that the set is A, E, I, O, U. Okay, so these are the elements of the set. It is well defined. Yes, it is a set. Now the question is how to represent the sets. Remember, generally sets are represented by capital letters like this, either A, B, C, D, like this. We are using capital letters to represent the sets. Generally, A, E, I, O, U, this particular set, example number 1, the set of vowels in English alphabet, if I take, and to represent it, there are different methods. First method is called as roster method, or tabular method. In this roster method or tabular method, you are directly representing the elements in the flower bracket. We will write it as A is equal to, right? See, this particular set A will contain, generally elements of the set are A, E, I, O, U. These elements of the sets are represented inside the bracket separated by comma. A, E, I, O, U. Remember, you have to use only flower bracket, but not the square bracket, but not the common bracket. You are not supposed to use them. Remember, generally, in a tabular method or roster method, the elements of the set are directly written inside the flower bracket separated by comma. You are not supposed to use a square bracket or a common bracket to represent the set. It is called as roster method or tabular method. The same set can be represented in another way. That is called as rule method, rule method, rule method or set builder method. But it is called as set builder method. We call it as rule method or set builder method. Set builder method. In this method, you are not directly rating the elements. You are rating the rule. Look at here. What is the rule? Set of all, say, x, such that. This is the method. This particular symbol, remember, generally we are using some special symbols. Today we are learning representation of the set, the first part of it. So generally some symbols are used. This particular Greek symbol, E, called as epsilon, Greek symbol, E, meaning belongs to. Remember these symbols we are using in the set theory, and this if a slash is written on it, does not belong to. Generally we are using either a slash or colon. If it is written, its meaning is such that. Look at here. I am using this particular line, right? A slash, a vertical line. It means x such that, or you can even use the colon, not semicolon, x, such that x is a vowel of English alphabet. Means in the set builder method, we are writing the rule. By which elements of the set can be obtained. X is a vowel of English alphabet. Look at here. The rule by which elements of the set can be written inside the bracket, then it is called as the rule method or a set builder method. Look at here. Right? Representation of the set. Mainly there are two sets. John Venn gave another method of representation of the set. We are using it while studying the next chapter, relations, functions, right? So there we are using generally in this Venn diagram method. What it's called as Venn diagram method. See, in Venn diagram, you are drawing a circle like this. Inside the circle, we are writing the elements with the dots. Say this is A, this is E. So same set A can be written as A, E, I, O, U. You are writing the dots. Elements are written in the circle. This is called as Venn diagram method. There are three methods mainly to represent the set. A set can be represented either by using roster method, or by using rule method, or by using Venn diagram method. There are three methods of representation of the set, and every member of the set is called as element of the set. What is element of the set? Element of the set. Very useful. The set theory is very useful in learning probability, in learning geometry also. Actually, it was while studying trigonometric series, it was introduced by Cantor, a German mathematician. Element of the sets. Generally, elements of the sets, every member, right? Every member of a set is called. Every member of a set is called element of the sets. It is called as element of the set. Take a pen and paper, go on jotting down the important points. It is not just I am not YouTuber, you are not subscribers who are here. You are my students. This is a classroom. Lokji channel is not a YouTube channel. It is an institution. If you keep this in mind, you will understand and jot down the important points. Hi, all of you. I am Gopi Charan. Welcome. Good evening. What is the name? Okay, welcome to all. Welcome to all. Okay. Good evening. Let us start. Continue the study. Every member of the set is called as element of the set. Element of the set. Generally, how the elements of sets are represented? Generally, elements of the sets are not represented by capital letters. We are representing them by using what? By using small letters. Representation. Right. How they are represented? Representation of elements. Elements are written with capital letters. Elements of a set. Elements of a set. Elements of a set are represented by elements of the sets are represented by small letters. Small letters. Suppose that it is alphabet, small letters separated by comma, and enclosed in flower brackets, or it is also called as braces. This symbol, flower bracket, right? The set of vowels just now we wrote can be written as A is equal to. In the rule method, we reprint it as A, E, I, O, U. I hope you understood that. So they are separated by comma. So in the 10th standard, recently we studied probability. Okay, probability. In probability, you are using sample space, isn't it? Say in probability. That is a tossing, throwing a die. So throwing a die, you studied in the 10th standard, is a random experiment in the probability. So the set of all possible outcomes, we reprint it as sample space. You recall, in probability, sample space. We used it in 10th standard. This sample space is represented by S. Okay. What are the elements of this set? So whenever a die is thrown, a die will have 6 numbers, namely 1, 2, 3, 4, 5, 6. So this is the representation of the set. We are using in probability. Already you used it in the 10th standard. Sample space on throwing a die. What is the sample space? Sample space is nothing but set of all possible outcomes. This is a well-defined objects, because in a die is nothing but a cube. It will be like a cube, isn't it? Like a cube. Okay. And every face will be numbered with 1, 2, 3, 4, 5, 6. There is what is the total number of outcomes? That outcomes is called as yes. Capital S, which stands for sample space. There we are using the set. Okay. So means we are using set everywhere, right? Even a very important thing is, you studied the number system in the 9th standard. Okay, number system in the 8th, 9th, 10th standard. Number sets. Very important while studying the sets here. That is a particular number sets are very popular. You studied in the right from the 7th, 8th, 9th standard, you studied number theory, number systems. Number sets. You know that the n is represented by the set of natural numbers. What are natural numbers? Natural numbers are counting numbers. So in the rule method, how do you write it? Sorry, in the roster method, the sets are represented by 1, 2, 3, 4, 5. How many natural numbers are there? Infinite number of natural numbers are there. Therefore, this particular set is called as infinite set. And the set which contains, for example, on throwing a die, the elements of the set are finite. How many? There are only 6. Therefore, such a set is called as finite set. The all number sets are infinite sets. And what W represents? You recall and tell me what W represents. The number set W represents, this class is for PUC1, my dear students. PUC1 set theory. PUC1 set theory. Okay, it is a class. For which class is this? It is for PUC1 science, first chapter. If you are a 10th standard student, join me at 8:30. Therefore, I told you, you please in the videos of PUC1, you will get the WhatsApp link. Join the WhatsApp link, and even in the WhatsApp, I will update everything. If you are a 10th class student, you join at 8:30 p.m. today. I am teaching there a trigonometry. Today I started PUC1, 8:30 p.m. I am teaching trigonometry. You can join me at 8:30. If you are a 10th class students, maybe CBSE, ICSE or state, combined trigonometry I am teaching there. Trigonometric identities I am teaching there. Even I have kept in the status of my number. You can save my number 9731571044. 9731571044. You can call me between 1 p.m. to 4 p.m. if you want any clarifications. 1 p.m. to 4 p.m. 9731571044. It is my WhatsApp number, and you save my number as a Desai Sir Log Z. Desai Sir Log Z. Okay, never get confused, because I am taking classes for different classes: PUC1, PUC2, class 10, state, CBSE, ICSE. Now PUC1 class is going on. W represents what? W represents a set of. W represents a set of whole numbers. Whole numbers will start from 0, 1, 2, 3, 4, 5, so on up to infinity. To represent infinity, you have to put the dots. Even if you put 3 dots, sufficient. Okay, it represents that it is a infinite set. What do you mean by infinite set? A set contains, right? A set contains infinite number of elements is called as infinite set. Next, you studied Z, or even we represent by symbol R. Z represents set of whole numbers. Remember, number sets. In the 9th class or 8th class, we have not introduced them as number sets. We used to write it openly, and now you learn it as a set of natural numbers. Set of natural numbers. Natural numbers are nothing but counting numbers. Natural numbers are nothing but counting numbers. Whenever you start counting, the counting will be started by 1, 2, 3. Whenever you want to count a number of students in a class, you start counting 1, 2, 3, 4. Okay. And set of whole numbers, right? When 0 was introduced by Indian mathematician Aryabhatta, the whole number set was X. The same set became bigger after the invention of negative integers, and from negative infinity, you will get -3, -2, -1, 0, 1, 2, 3, so on. So here up to negative infinity, here up to positive infinity. And this set is called as a set of integers. Remember, set of integers. Set of integers. So this method of representation is called as roster method of representation. Set of integers. Integers will include negative numbers, 0 and positive number. Right? First, smallest set is number set. Number set, whole number set is bigger than this natural number. All natural numbers are present in whole number, and set of integers contains whole numbers, natural numbers, as well as negative numbers. That is called as set of integers. Remember. And next set is a set of Q. What is Q? Is set of rational numbers. Set of rational numbers. You studied in 9th standard and 10th standard about rational numbers. irrational numbers. Even you studied, proved irrationality of root 2, irrationality of root 3, such numbers. You can define it very neatly by using set builder method. How do you represent set builder method? Set of all p by q such that, what this colon represents, such that p comma q belongs to z. Means what? P and q are belongs to, what the symbol stands for? Belongs to. Remember the symbols. Belongs to z. Clear? Now, and q should not be equal to what? 0. The rule by which you can get the elements of the set is called as rule method. The set of rational numbers, that is can be represented by the symbol q, and it can be well defined by using the set builder method, or we commonly call it as rule method. I hope you understood the methods of number sets. And another set is there called as q dash. What q dash is? Set of irrational numbers. Irrational numbers means what? You cannot express these numbers in the form of p by q. Means what? All integers are rational numbers, because you can write integers minus 3 by 1, minus 2 by 1, minus 1 by 1. 0 is also a rational number, because 0 can be written as 0 by 1, 1 by 1, 2 by 1, 3 by 1. These number sets will go on increasing, right? And this particular set further extended to, these are called as irrational numbers. Irrational numbers cannot be expressed in the form of, p by q, which cannot be expressed in the form of p by q. This set of irrational numbers is also infinite set. And these irrational numbers were started for the first time. We discussed in the 9th standard only. Just I am recalling you. You know, Pythagoras theorem you studied in the 9th or 10th standard. Pythagoras theorem. It was the Pythagorean team was working with. You know what is the Pythagoras theorem? This is the hypotenuse, square on the hypotenuse is equal to, already we are studying in trigonometry. So already we started the bridge course in trigonometry, combined all PU7, class 10 combined. So there we discussed in length. This is the side opposite to the right angle is called as hypotenuse side. What it is called as? Hypotenuse side. This is called as base in geometry, and this is called as altitude. What is the summary of Pythagoras theorem? Pythagoras theorem tells us that square on the hypotenuse is equal to sum of the squares on base square plus what? Altitude square. Square on the hypotenuse in a right angle triangle is equal to sum of the squares on in the trigonometry language we write it as adjacent side. If it is a reference angle, this is called as opposite side. Already we discussed in length, right? Already we are in last part of the trigonometry. That is the trigonometric identities. All PU1 students who are not perfect in trigonometric identities, you can join me at 8:30 along with the class 10 students. If you are not perfect in the 10th standard, you have no sound base in trigonometry, you can watch my videos or watch my live stream videos in the Lokji channel, or you can come live at 8:30. But to start the PU1 syllabus here, now why I am taking this Pythagoras theorem is, the Pythagoras team was working with application of this. Suppose that you take 3, 4. What will be hypotenuse? 5. Because 5 square is equal to 3 square plus 4 square. 4 square. That is 25 is equal to 3 square is 9, 4 square is 16. Therefore 25 is equal to 25. Means 3, 4, 5 are called as Pythagorean triplets. What they are called as? They are called as Pythagorean triplets. Remember, They are required later in trigonometry, Pythagorean triplets. Very important. Later in trigonometry, Pythagorean triplets. And the problem that came was when they took Pythagorean team took this particular base also 1 or adjacent also 1 and opposite also 1. Then what will be hypotenuse? You can get hypotenuse as AC square is equal to AB square is 1 square, BC square is 1 square. What do you get here? AC square is equal to 1 plus 1. What do you get? AC square is equal to 1 plus 1 is 2. Therefore, AC is equal to root 2. Observe, this root 2 was surprising for them. This particular root 2 was surprising for them. Why? Because root 2 was neither a natural number, all these numbers. First set is natural number, bigger than that is whole number, bigger than that is a set of integers, bigger than that is rational numbers. And this particular root 2 couldn't belong to any of these natural numbers, whole numbers, integers and rational numbers. Therefore, this particular numbers like root 2, irrational roots of rational numbers, root 2, root 3, you studied in 10th standard, proved irrationality of irrational numbers, and even you studied solid paper also, such numbers, right, which do not belong to any rational numbers were called as irrational numbers. You cannot express them as root 2 by 1 because the numerator p does not belong to what? Integers. Therefore, all these numbers are considered as irrational numbers, right? That is the difference between rational and irrational numbers. Irrational numbers. Irrational numbers. So, these particular rational numbers and the set of rational numbers and set of irrational numbers, you try to understand set theory, particularly with respect to the numbers, number system. And up to school level, 10th standard, the concept of set was not introduced to you and it is introduced from the first PU. Therefore, you are learning them as a number sets here. Understood the origin behind the irrational number? Origin behind the irrational number is Pythagorean team was working to find out when both of them are, this is isosceles right angle triangle with each side 1. So then they got a number which is neither a natural number nor that particular whole number or integers or rational number. Therefore, these numbers were called as irrational numbers. What are irrational numbers? Which cannot be expressed in the form of P by Q. What is the condition of rational numbers? Rational numbers is, just now we told that Q is equal to, this is called as rule method. Set of all P by Q, this symbol stands for such that PQ belongs to what? Belongs to, this symbol is Greek symbol, epsilon, belongs to the Z and Q is not equal to 0. Remember. Now observe here, root 2 by 1. 1 is no doubt. 1 is no doubt a rational number, but what about root 2? Root 2 does not belong to the natural number, therefore these do not belong to the rational numbers, these are called as irrational numbers. So that is the bigger set. And these are rational and irrational numbers together called as another set you studied in the 10th standard, first chapter, called as real numbers. Set of real numbers, okay, set of real numbers. Can any one of you tell me what is set of real numbers? Set of real numbers. Set of real numbers can be represented. Suppose that I ask you to represent set of real numbers is generally represented by R, right? It is the set of all x. In rule method you can write set of all x such that x belongs to Q or x belongs to Q dash. Means what? X belongs to both the rational numbers or irrational numbers. Rational numbers and irrational numbers together will come under the set of the real numbers. Means what are real numbers? It is a set of bigger set of all rational and and irrational numbers. Set of all rational and irrational numbers. Set of all rational and irrational numbers. Don't write and here. Set of all rational and irrational numbers is called as set of real numbers. Are you getting me? Set of real numbers. Like this, the number sets went on increasing, and another problem came to the mathematicians. The problem was that I will give a simple problem to you. Solve this. Solve for x. I will give simple equation, a quadratic equation. Solve this and tell me your answer. What is the solution? No. Whenever you want to solve this, first of all, you have to take plus 1 to the right. What do you get? X square is equal to what? Minus 1. Then what is x is equal to? You studied at the school level. Square root of it. Taking square root on both sides. Taking square root on both sides. Square root on both sides. Square root on both sides. What do you get on taking square root on both sides? You will get x is equal to plus or minus root of minus 1. Observe very important fact, that is under root negative numbers. Under root negative numbers does not belongs to what? Does not belongs to the biggest set we know, that is real number set. Real number sets will have under root positive numbers only. So root 2 is called as irrational. Root 3 is called as irrational. Root 5 is called as irrational. Have you observed any irrational number like this? Under root minus 7? No. And this problem came. Therefore, another set was introduced. That set is called as set of complex numbers. What they are called as? Set of complex numbers. Right? Or the set of complex numbers is the biggest set. You have a chapter also, I think, in mathematics. Complex number, chapter number 4. Chapter number 4. You are studying complex numbers. Right? Chapter number 4. You are studying complex numbers. Right? This complex number set is the biggest set known to us now. Set of complex numbers. Generally, we represent it by a symbol again by Z, set of complex number, or we can write C, set of complex numbers. And what are complex numbers? The under root of minus 1, right? It was given by the symbol I. I stands for imaginary or iota. Iota, imaginary numbers. You studied nature of roots, quadratic equation. Recall, nature of root. So you know that the Sridhara's formula, what is a discriminant in quadratic equation? Recall and tell me, you studied in 10th standard. Root of, that is b square minus 4ac. Actually, it is a part of a quadratic formula. What is the quadratic formula? Minus b plus or minus root of b square minus 4ac upon 2a. Isn't it? And in the chapter, that is a quadratic equation, you studied if delta is greater than 0, delta is equal to 0, delta less than 0. What you used to call it as? Delta means this total thing. Under root. If delta is greater than 0, means root of positive number. If it is there, then the roots are real, and you wrote, do you remember 10th standard? Real and distinct. When a delta is equal to 0, how the roots are? Delta is equal to 0. Delta is equal to 0 means under root 0 will be what? 0 only. In that case, you used to say that it has got only one root. Roots are equal. You know? Roots are equal. And 10th standard, roots are equal. Now, the part is when this under root is a negative, means under root negative numbers iddu andre alli ನಾವು 10th ಒಳಗೆ ಹೇಳಿದ್ವಿ ನಾಟ್ ಎ ರಿಯಲ್ ನಂಬರ್ ಅಂತ ಹೇಳಿದ್ವಿ. ಬಟ್ ಇಲ್ಲಿ ಹೇಳ್ತೀವಿ ನಾವು ಫಸ್ಟ್ ಇಯರ್ ಒಳಗೆ ಇದಕ್ಕೆ ಕರಿತೀವಿ ನಾವು ಇಮ್ಯಾಜಿನರಿ ನಂಬರ್ಸ್. ವಾಟ್ ದೇ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಇಮ್ಯಾಜಿನರಿ ನಂಬರ್ಸ್. Imaginary numbers. Note down the facts. So very terrible. Note down the facts. Open the notebook. Jot down the points. Don't see like a video or cinema. You will never improve your mathematics. keep a pen and paper, jotting down, working with me in my speed of writing. You have to jot down the important points because I'll be discussing things here, solving problems here. And if you write, the things will go to permanent memory. Otherwise, they will be in the RAM, random access memory. Like in a computer RAM, if you do not save it, if you write it, the things will be saved to the memory. I am just recalling you where you came across the complex numbers. So nowadays the biggest set is the set of complex numbers. How to define a complex number? A complex number will have the two parts. C is equal to, we write it as x plus iy such that x, y belong to what? Real numbers, and I is equal to root of -1 is the definition of complex number. Remember, my dear students, is called as complex number. In chapter 4, we are studying about the same thing. As I am talking the set theory is very useful, fundamental thing. And this method of representation is called as set builder method. What it is called as? Set builder or rule method. Set builder or rule method. Okay. How do you define the complex number? Complex number is a set of all x plus iy such that where x is called as real part. What it is called as? Real part. And what is y is called as? Y is called as imaginary part. What it is called as? Imaginary part. Imaginary part means under root negative numbers. Under root negative numbers where I is equal to root of -1, like 2 plus 3i. This is a complex number. 3 minus 4i is a complex number. Right? 7 plus 8i is a complex number. Where this I represents iota given by Euler, this is root of -1. You will be studying about it, a complex number. So thus we studied the origin of irrational number and origin of complex numbers. And if you go on drawing the circle here, you can remember number sets very easily. Earlier there was only one set. I will draw the first circle, that is n. Bigger than that is the whole number. After that comes the integers. Integers will contain both whole number as well as natural number. And bigger set than this is, yes, you have q, means rational numbers. And bigger than this set is the set of real numbers. And our biggest set known up to date is the set of complex numbers. Means, so the development of the number set is one of the wonderful development. Set of natural numbers will start, counting numbers start from 1, 2, 3, 4. Whole number includes 0 after the discovery of 0 by Aryabhata. And then the negative numbers were invented. Right? So then rational numbers were invented. Then real numbers were invented. What is real number? Real number consists of both q as well as q dash. Q dash means irrational number. Q means rational numbers. Are you getting me? And then comes what? A set of a complex number. This set of complex number is the biggest set known to us. And these number sets will go on increasing their volume. And you will be learning complex numbers in the 4th chapter. Therefore, I introduced the number sets. I hope you understood the things in the first topic. I'll give you solve some questions on it from the exercise. What you studied is what is a set? What is the summary of what all we studied so far? We studied so far what is the definition of the set. First part, the introduction part of it, or representation of the set. Set definition and representation. In this particular topic, first topic, representation. Okay, representation of the set. So there are just refreshed that a set is a collection of well-defined objects. And there are 3 methods of representation. First method is called as, yes, roster method. Remember, what is roster method? Recall. Second method is set builder method, set builder method, set builder method. And the third one is Venn diagram method. You will be studying in later part of the chapter. Venn diagram method. Right? Here we are using some symbols. Right? There is a studied roster method, set builder method, and all number sets we studied. Right? And what is not a set? What is a set? What is the meaning of well defined? We discussed in length. Okay. Now we'll see few problems in the exercise. Right? I will read out some of the questions from exercise 1.1. Right? Some selected questions. They will be very easy. You can open your textbook, exercise 1.1. I will solve some selected questions. Some of them orally you can answer just to check your understanding. Okay. Open the textbook. First question, exercise 1.1. First we will see level 1 problems. Level 1 questions from the textbook only. NCERT textbook. Bring a textbook. Have separate notebook of PU7 mathematics. Logzi live stream. Don't ask questions for me, sir, please. Yes. Now I will start asking you questions from the textbook, dear student. You try to answer now. I will read out the first question. You can also answer, all of you. Which of the following are sets, sir? Justify your answer. First question. The collection of all months of a year beginning with the letter J. First question. Exercise 1.1. Open the textbook. Okay. First question. A collection of all months of a year. ಈ ಲೈಟ್ ನೋಡ್ತೀರಾ ಕರೆಕ್ಟ್ ಬರ್ತದಲ್ಲ. A collection of J. You start A ಅಂತ ಅನ್ಕೋಣ. You write J. January comes. January comes in it. January. Check whether February comes. January, February, March, April, May, June comes. July comes. July, August, September, October, November, December will not come here. Therefore, is it a set? Yes, it is a set. Justify your answer. Why? Because they are well defined. Reason is only one reason. Because the January, June, July are well defined months of the year. Therefore, it is a set. Second question. Okay. You try to answer the question. The collection of 10 most talented writers of India. It is not a set. Why it is not a set? Give reason. Not a set. Why it is not a set? See, the collection of 10 most talented writers of India. We cannot just distinguish between the talents, and it is their personal ability. So, therefore, it is not well defined. Reason is not well defined. Right? For some people, some person they may feel talented. For some other authors, some others may feel well defined in some other language. Therefore, we cannot say it as a set. A team of 11 best cricket batsmen of the world. Impossible to decide. Not a set. Why it is not a set? For some people, not a set. For some of you, you may feel that Kohli is the best batsman, Tendulkar is best batsman. Some of them may feel, Vaibhav Sooryavanshi is better than Sachin Tendulkar. Like that, we cannot define. Not well defined. The reason is not well defined. Should be your answer. Yes. Next question. The collection of all boys in your class. Is it a set? Collection of all boys in your class. Nodri. Suppose that yes, it is a set. Okay? ನಿಮ್ಮಲ್ಲಿ ಎಷ್ಟು ಬಾಯ್ಸ್ ಇದ್ದೀರೋ ಅವ್ರ ಹೆಸರು ಬರೀಬಹುದಲ್ಲ? Yes. Yes, it is a set. It is a set. Justify your answer. Because well defined. It is a well defined. Because the set of boys you can collect. You take the attendance book, collect all boys, list them in a tabular form, then you will get a set. It is well defined. It is a well defined. And first step is to identify which is set, which is not a set. Then fifth question. The collection of all natural numbers less than 100. Look at here. Fifth one. A collection of natural numbers less than 100. Can you list? Yes, you can. You can list them. A is equal to collection of natural numbers 1, 2, 3, so on up to 99. Is it not well defined?
Yes.
A collection of natural numbers less than 100. Right? Yes, it is a set. Because well defined. Sixth one. A collection of novels written by the writer Munshi Prem Chand. Can you write? Yes, it is well defined. Yes, it is a set. You have to identify because it is well defined. Right? Seventh one. The collection of all even integers. Look at here. All even integers. All even integers. What are the even integers? 2, 4, 6, 8, so on. Even negative integers also. Means a collection of all even integers is a set. Yes, it is well defined. What about eighth one? A collection of questions in this chapter. Questions in this chapter. Eighth one. Is it a set? Yes, definitely it is a set. Ninth one. A collection of dangerous animals of the world. No, it is not a set. Why? Because we can't say which animals are. There are animals which cannot be seen with our eyes, right? Animals of the world. In the world, so there are many animals which is dangerous, which is most dangerous, we cannot decide. Therefore, not well defined. Reason is not well defined. That is the first question. Clear it to you? Just to check your understanding level, these questions are given here. The first main question is of exercise 1.1. We studied level 1 questions. Then I will take next level questions, right? Observe the use of belongs to and does not belongs to. A set is given in the second problem. You can see in your textbook. That is 1, 2, 3, 4, 5, 6. They have given to put the symbol 5-A. Second one. 8-A. Third question. Very simple to test your ability to use 0-A. And the fourth one is 4-A. And the fifth one is 2-A. And the sixth one is 10-A. Now you put belongs to, does not belongs to symbol. Does 5 belongs to A? Yes, belongs to A. 8 doesn't belongs to A. Epsilon. This symbol is a Greek symbol. It is a Greek symbol. Meaning of it is epsilon. Remember, if anybody asks you, you can answer. It is a Greek symbol, epsilon. 0, not present in it, therefore does not belongs to. Fourth, belongs to A. Belongs to A. 2 belongs to A. What about 10? Does not belongs to A. Just the author is trying to make you to learn use of symbol belongs to. Next one, very important. Write the following sets in the roster form. They have given it in the rule method set builder form. Set of all x. Hang odbekidena nodri. Set of hang odbeka. Set of all x such that x is an integer. X is an integer. X is an integer. Integer. And condition is given. -3 is less than or equal to x. X is less than or equal to 7. Take 5 to 10 seconds. Write the answers. Try, all of you. Try to write a given set builder method. You must get what? You must write, right? Exercise 1.1. Basic understanding, basic concepts are cleared by NCERT. What is the meaning of this symbol? This symbol, remember, less than and equal to. Remember, less than, equal to. Many students have got doubts. 10th completed students, this symbol, if it opens to the right side, then it is less than. If it opens to the left side, then it is greater than. Remember, you can note down the symbols also. This symbol, already we got a symbol. You make a separate slip. This belongs to. Note down some symbols. Belongs to. This note down some symbols. Does not belong to. Does not belong to. Look at here. If I use the symbol like this, many students I have seen in the school, they confuse. If it is open on the right side, then it is called as less than. Less than. And if it is a line is written along with this, it is called as less than and equal to. Note down symbol. Those who do not know, less than and equal to. Less than and equal to. If I write the symbol like this, if it opens on the left side, if it opens the mouth on the left side, remember, never get confused. Greater than. Many students don't know which is their right hand and which is their left hand. Never get confused. If it opens on the left side, it is called as greater than or equal to. It is called as greater than or equal to. Greater than or equal to. I am using number of symbols. You can write, you leave 1/4 place in the maths classwork book. You note down such things, extra information, greater than or equal to. What is the symbol? This either colon or the vertical line represents such that in the number set. Note down. Such that. Then if I use the symbol like this, if I write capital U is different, but I am drawing this diagram. It is a symbol used for union of sets. If I write this symbol, remember, it is intersection. Clear it to you? Intersection of the sets. If there is A union B, later in the operations you will be learning A intersection B. Clear it to you? Some symbols, if I write this symbol, 3 dots like this, it is a therefore. If I reverse it, if I do like this, 2 dots and below that another dot, this is a because. What this arrow mark like this represents, implies. What it represents? Implies. Generally used symbols in mathematics. You must know about it before you start. Observe and write the elements of the set A. Okay, fine. Tell me, what are the elements you wrote? That is flower bracket. You start with -3 is less than or equal to x. X is only less than 7. Means you have to include what? -3. Then comes what? -2. Then comes -1. Then comes 0. Integers. 0. Then comes 1, 2, 3, 4, 5, 6. Stop. Because less than, not equal to. 7 is not included in it. No. Don't write open bracket. You have to write the set like this. And less than is there. If it is equal to it, andre 7 baribodagitte. Less than 7 andre you have to stop at 6 only. It is an integer. Integer starts from -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Stop. 7 you will not write. Open bracket, close bracket is a different intervals. That is a different thing. You will be learning in later stages. Second question. B. You are given with a set of all x such that x belongs to natural numbers. X is a natural number and x is, I am writing in symbol, less than 6. Now you can write easily. I am not writing words there. What are the elements? You have to write it in the roster method, given rule method. What are the numbers? How do you start? You can write it as less than 6. 1, 2, 3, 4, 5. Stop. 6 will not. Less than 6. Less than 6. Right? Now, time is up. Okay? Time is up. We'll stop today. And you try all the 6 problems of the exercise 1.1. Right? Yes, you have to complete. If you have got any doubts in this one, you can inform me. And what you are asking? Sir, belongs to such that both कुछ और बोलते हैं. क्या बोलते हैं? क्या बोलते हैं? Belongs to, does not belongs to. Only one symbol, not belongs to. Okay? Yes, sir. We'll stop now. We'll continue tomorrow with the chemistry, alternate day, some basic concepts in chemistry, very important topic, mathematical part of it. I'll be discussing about units, conversions. We started it, continue in the next class. And if you like these classes, ask your friends to join our Logzi family, right? And even download Vedim's app to improve your basic mathematics. Okay? Right? And I will, I have put in some videos already the WhatsApp group of PU7. Click there. You will directly join the group there. And join the group, then only I will send you some assignments. This is first level, you consider it as a NCERT text. Next level, I will give you different questions. Some MCQ tests I will send you in the WhatsApp group, PDF. You can solve them and ask me the difficulties. Okay, continue in the next class.